morning, grade 12s. It is Thursday, May the 7th as you are watching this, and I just want to welcome you to our new unit. We are starting a unit on electricity, and hope you liked the new intro, kind of an electric soundtrack created by Joel. The pictures are a progression of pictures of me from day one of school classes being suspended, and the day when I shaved off the rest of the facial hair. So you could sort of see the progression as you go through that intro. And yeah, so new unit, new intro. All right, before we get started today, I just want to give you our verse of the day today. Today it comes from Psalm 130, verse 5. Where it says, I wait for the Lord, my whole being waits, and in his word I put my hope. So again, just a reminder of where our hope should lie. Our hope should lie in the words of our Savior, in the words of Jesus, in his word, and not to put our hope in the things of this world per se, but to put hope in his word. So, as we get started today, we are going to start this unit by just looking at a very simple and short definition of current electricity. And so I've only got the one board, which is behind me, a little bit of information on it. It's all we're going to cover today. One short, simple, 3 variable formula. I'm going to give you 5 questions to do on a handout. And it should be fairly simple and fairly easy. It'll give you time to continue to work on the test if you haven't already completed it. So here we go, current electricity. So what I've drawn here is I've drawn a little bit of a wire here, and I'm actually going to erase this for a moment. And what we've got is we've got a wire, and in this wire we have electrons. The electrons are flowing this way through the wire. All right. Now current is defined as the amount of charge that is passing this point. We called it A. I called it A. So how many coulombs, how many electrons are passing that point in an amount of time? That's what current is. So it's almost like a velocity, right? Instead of a meter per second, it's coulombs per second. And a coulomb is a measure of charge. And again, I want you to remember that the charge on every electron is 1.6 times 10 to the negative 19 coulombs. So that's the charge on one electron. Current is how many electrons, how many coulombs are passing this particular point in an amount of time. So it gives us a formula. I is the symbol for current, and Q is the symbol for charge, and charge again is measured in coulombs, and of course time is measured in seconds. So we get current equals charge over time, Q over T. That's our formula, that's our 3 variable formula. Current is measured in amps, as I'm sure you are all aware that current is in amps. Whether you learned it somewhere or not, you probably heard that at some point that we have an amount of amps in an electrical circuit. And again, 1 amp is defined as 1 coulomb per second. All right, now, the thing that I erased was a directional part. And again, this is just simply based on technology. When scientists were doing initial investigations on current, on moving electrons, they defined current as moving in one direction. And then as technology improved, they realized actually that it was the electrons that were moving that created the current, and electrons actually moved in the opposite direction from what they had defined current to be. So we continue to use that initial definition of current, or the direction of current, and it is in this direction in this diagram. Okay, so while the electrons are moving left to right, current is defined as moving right to left. So current and the electrons move in different directions. So current is a concept, right? The electrons are moving, in this case, left to right, but we define current as moving right to left. Okay, so just keep that in mind, that there's a difference between the direction the electrons are actually moving and the direction of current. That will become important later on as we get into electromagnetic induction and the whole idea of using transformers and generators to create and distribute our electrical energy. All right, so that's all I want to give you is this formula right here. I equals Q over T. 3 variable formula. I'm going to give you a handout that will have 5 questions on it based on this formula. Should be fairly straightforward. It's going to give you 2 of the 3 pieces and you've got to solve for the 3rd. You are all good algebra students. I know you can do that. So, and the answers of course will be on the paper as usual. That's it for today. Work on your test if you haven't finished it already. Get that submitted to me using Connect. Look for this video and the assignment on Connect. And that's it. We will see you tomorrow. Have a good day.